We've been talking about compound sentences. We're at 9.2c in Algebra I, and this is disjunctions and unions. We can solve and graph a disjunction of two inequalities in one variable. A math sentence like x is less than -3 or x is greater than 6 is called a disjunction. We can tell because of that word or. A disjunction of two statements is made by connecting them with the word or. A disjunction is true when one or both statements are true. So notice all the times we used or. When we did a conjunction, we used the word and. So for a conjunction to be true, both statements had to be true. In a disjunction, it's or, one or both statements. See, the conjunction was definitely just both, all right? A disjunction of two statements is like the union of two sets. So we have our union sign here. Remember, a conjunction was like an intersection of two sets? The solution set of a disjunction is the union of the solution sets of the individual statements. So it's what's in one or both. On the number line, when we graph it, there will be two separate sections that we graph. Let me show you. It says to graph the disjunction x is less than -3 or x is greater than 6. Because of that word or, we're going to have two sections that we graph. See that? When we did the conjunction, we only had one section, right? Now we've got this side and this side. It's because of the word or. It's a disjunction with the word or, so two sections of the number line are graphed. If you can remember that, conjunction is one section, disjunction is two. Conjunction is like an intersection with and disjunction is a union with or, okay? If you can remember that, that's really going to help you, okay? So we know that x is going to be less than a -3, so it's going to go into the smaller, into the more negative numbers, isn't it? But it doesn't include -3, so we put the open circle here, and then our arrow's going towards, negative infinity here. And it's greater than 6, so it doesn't include 6, so we've got an open circle, and it's going towards positive infinity, isn't it? In set builder notation, we would just write it just like this, and we would put our set braces, and we would put an x and the such that bar, wouldn't we? In interval notation, because we never put a bracket next to an infinity symbol, we have negative infinity on this side because it is going into negative infinity, isn't it? And it doesn't include this -3, so we've got a parentheses on both sides. And on this side, it doesn't include the 6, so we have a parentheses and then the 6, a comma, and then the positive infinity, because it's going towards positive infinity forever, isn't it? Now this one's going to be a little tricky, so pay attention to this one, okay? You might even have to watch the video twice, but I'm going to repeat it as much as I can. We're going to solve and graph this one. We're going to start by solving each inequality separately. So let's start with this one. We've got -3x minus 4 is greater than 8. So we know we can add 4 to each side of the inequality sign to create a zero pair right here, right? Get rid of that, eliminate it. Now we've got a -3x is greater than 12. We can divide each side by this -3, can't we? To isolate that x, right? Because -3 over -3 makes a +1, so we have a positive x. And on this side, we have a -4. But we have to reverse the sign. We have to reverse the sign because our answer needed to be divided by a negative. We reverse the inequality sign. Whenever we multiply or divide by a negative coefficient, we have to reverse the sign. You might want to write that down. Whenever you're isolating for a variable and you have to multiply or divide by a negative coefficient to isolate that variable, you have to reverse the sign, okay? Multiplying or dividing. So here we're dividing by a -3. We had to reverse the sign, see? And we had x was greater than -4, but now it becomes x is less than -4, see? On this side, because it's got a -6, we can add 6 to each side. That one's easy. That creates a zero pair here, and we have x is greater than 7. Now this is our solution, see? And because it doesn't include -4, we've got an open circle, and then it goes towards negative infinity. And because it doesn't include 7, but it's greater than it, we put an open circle on the 7, and it goes towards positive infinity. And depending on how you want to write the answer in interval notation or set builder notation, we just take this x is less than -4 or x is greater than 7, and we put the set braces on it with the x and the such that bar, and then we've got our answer, right? And for interval notation, it doesn't include the -4, so we've got a parentheses on this side with the -4, and it goes into negative infinity. So we've got our negative infinity there, and on this side, we've got, it doesn't include 7, so it's got a parentheses, and it goes on to positive infinity. See? So just remember that with interval notation, and if you're not using that right now, that's okay. I just like to teach it now because you're going to use it in Algebra II anyway. So you may as well introduce it, right? So just remember, if it is included because it's or equal to, then it's a bracket. If it's not included, we still put the number with a parentheses, and infinity always has a parentheses side. It never has a bracket on its side, okay? A conjunction is graphed as one section on the number line. So when you see it on the number line, it's only that one section. That's a conjunction. The disjunction, you're going to see it's like broken up into two parts. It's going to be that side of the number line and that side of the number line. The conjunction is just one. See? That's going to help you because that's the and that's the or. If I said you have a choice, I'm going to give you a chocolate cake or a yellow cake. I didn't say I'm going to give you both. I'm going to say I'm going to give you one or the other. So there's two choices. If I said I'm going to give you chocolate cake and yellow cake, then that's combined. It's together. See? And remember, an element is in a union of two sets if it's in either of the first or the second set. And disjunctions can't be written in combined form like this conjunction, -3 is on this side, and we've got this +5 on this side, and it's read as x is greater than -3 and x is less than 5. That's only for conjunctions because of the word and. You don't do disjunctions. That's got an or, so you can't write it in the combined form like that, okay? And remember, when both sides of the solution are multiplied or divided by a negative sign, we reverse the inequality sign. So if we're trying to isolate for x, and there's a -2 here, so we got to divide both sides by -2, well, we do our solution, x is less than -5, but then we flip this sign around. Now x is greater than -5, see? And when we start doing fractions, we'd have to multiply both sides by the reciprocal of the coefficient, right? And the reciprocal is the upside down version. So we'd have -2/3. We multiply both sides by a -3/2. Well, because we're multiplying by a negative on each side, we have to flip that sign around. See? So multiplying or dividing when you isolate the variable, okay? You got to flip that sign. And I guarantee you, the teacher or somebody is going to put it on a test with the sign going the wrong way. And if you don't remember, you're going to say, I did my math correctly. It's going to, to that side. And it's because you forgot to flip it. So they're going to try to trick you, okay? Just remember, when you're isolating for the variable and you have to multiply or divide both sides by a negative, flip that sign, all right? In our next video, we're going to talk about truth tables. That's in 9.2D. And if you want to link, just look in this video's description and you're going to see a link to all the previous videos, 9.2 A, B, C, and D, and a couple others that'll tell you about these conjunctions and disjunctions and intersections and unions. So if you just kind of happened along this video and you're lost, go back to 9.1A or 9.2A, and that's going to help you. And there'll be links in this video's description to get you there, okay? I'll see you at Truth Tables. Bye.